I'm going to do the graphing part of the study guide, and there will be a second video that does everything else. Um, so the problems that we're going to be doing are just graphing the rational functions. So I have 3 over x minus 1 times x squared minus 4. First thing that you have to do is find the domain. So what we want to do is actually simplify this. So this becomes 3 over x minus 1, x plus 2, x minus 2. And then my domain, the denominator cannot be 0, so my domain, so this is letter A, my domain is all x such that x cannot equal 1, x cannot equal negative 2, and x cannot equal 2. Letter B is to find my x and y intercepts. So to find my y-intercept, I set x equal to 0. If I set x equals to 0, it does not matter where I plug this in. I could plug it into here or here. And what I end up getting, I'll plug it into the top rational expression, and I would get 3 over negative 1 times negative 4. So my y-intercept is 3/4. Negative 1 times negative 4 is 4. Now my x-intercept is where y is equal to 0. Now, y is equal to 0 is going to be r of x. Remember, r of x is just another way to say y. So I have 0 is equal to 3 times x minus 1, x plus 2, x minus 2. Now, however, to find when y is 0, we could just eliminate the denominator, and we'll get 0 is equal to 3, which does not make sense, so we have no x-intercept. There is no x-intercept. Now, the next thing that we have to do is find the asymptotes. So I'm going to erase this. And the asymptotes are where, after you simplify this, so remember we simplified this to get 3 over x minus 1, x plus 2, x minus 2. My vertical asymptotes, and I'll make it VA for vertical asymptote. Vertical asymptotes are the zeros of the denominator. So my vertical asymptotes are x is equal to 1, x is equal to negative 2, and x is equal to 2. Make sure you put x is equal to, since they're equations of lines. My horizontal asymptote, we actually have to look at what case we have here. Now, in this case, the degree of my denominator is a degree of 3, since I have x, and x. There's 3 x's, so this is going to be x to the third. And that's greater than my degree on top, which is a 0-degree polynomial. So my degree on the bottom is greater than my degree on the top, so that means in this case my horizontal asymptote will be y is equal to 0. This will always be the case when the degree on the bottom is greater than the degree on the top. Now the next thing we have to check, so this is part C and this is part D. So part E asks you to find if the graph crosses the horizontal asymptote. The way you do that is you take the horizontal asymptote, which is 0, and you set it equal to the simplified function. So this is going to be 0 is equal to 3 over x minus 1, x plus 2, x minus 2. And we already did this with the x-intercepts. This can't happen. 0 cannot equal 3. So we don't cross horizontal asymptote. So that's part E. We don't cross the horizontal asymptote. Now the last part is to graph it. And it was my fault for giving you a small graph to graph this. I suggest for this problem to actually do your own graph because you have a vertical asymptote at 1 and 2, and that's really narrow in the graph I gave you. So I'm going to do my own graph, and I suggest you use your you just use the space on the right to do a graph. So I know a couple of things. I know I have a vertical asymptote at 1. I know I have a vertical asymptote at 2. I know I have a vertical asymptote at -2. And I have a horizontal asymptote at 0. Okay. I also know that I have a y-intercept at 3/4. So if this is 1, I know I'm going to intercept the graph at 3/4. Now, part F asks you to graph it, and you have to use a test point to figure out how the graph looks like. So if this is 2, I cannot use 2 as a test point. I'm going to use, I'm going to test the point to the right of this. Now, if I test the point 3, and I plug 3 into here, what do I get? I get r of 3 is equal to 3 over 2 times 5. Right? 3 minus 1 is 2, 3 squared is 9, 9 minus 4 is 5. And so r of 3 is equal to 3 over 10. Now that means at 3, which is right here, I'll be at 3/10, which is really, really close to the x-axis. Now, remember, in this problem, I do not cross the horizontal asymptote at all. So since I'm above here, I know that it's in the positive section, and it's going to form that, that shape that we always see with rational functions. I know that since I go through the point 3/10, I'm going to start up here, and then I'm going to approach the x-axis but never touch it. And then I'm going to go up, and it's going to approach the vertical asymptote and never touch it. And now I know some of you might ask, how come the graph doesn't go up like this? Well, remember, as x gets larger and larger, look at where x is located here. If x gets larger and larger, the denominator will keep getting larger and larger. So the numbers here get smaller and smaller. So I do approach the line y is equal to 0. Now, this is odd. These are all odd multiplicities. Now, if this goes up this way, I know that if I have an odd multiplicity at the vertical asymptote, on the other side, I'm going to be going down. Okay. Now, this graph just can't end here, but it can't cross the horizontal asymptote since we already figured that out. So it has to go somewhere, so it's actually going to loop back around and go down this way. Now, once again, what happens here? This is an odd multiplicity since I have my multiplicity of 1. So that means at this vertical asymptote, I have to go up. And look, I actually have my y-intercept right here. So I know I'm going to go up, and I have to come down to cross that y-intercept. But remember, I do not cross the horizontal asymptote here. So I cannot cross it. It has to go up here, has to go through the y-intercept, and then it's going to loop back around and form and go up this way. Remember, it can't cross the horizontal asymptote. And then since this is an odd multiplicity, you could expect this graph to go this way. And you could actually double check your work by plugging in a point right here. If I plugged in r of -3, I would get 3 over -4, 5. right? Negative 3 minus 1 is negative 4. Negative 3 squared is 9. 9 minus 4 is 5. So I get 3 over negative 20, or negative 3 over 20. So I know at negative 3, I'm at negative 320, which is really close to the axis. So I know I'm below the horizontal asymptote, which makes sense because since this is an odd multiplicity, this has to go up and this has to go down. So I know my graph ends up looking like that for that problem. Right. So once again, you have to use the multiplicities to figure out the direction of the graph at the vertical asymptotes. But to find initially where it starts, pick a test point, because I'm going to look for that on the test, and plot the test point, and then that will tell you if you're in the positive or in the negative section. And then use the multiplicities and whether you cross the horizontal asymptote to determine what the rest of your graph looks like. Okay, so that's the first one. Now let's go to the second one. The second one is r of x. And so now we have two different polynomials. We have r of x on top. It's x squared plus x minus 12. And then the bottom is x squared minus x minus 6. So first thing we're going to do is we're going to factor it so we could get a simplified version. So r of x is equal to x plus 4, x minus 3. And then on the bottom, I'm going to have x minus 3, x plus 2. My domain for a, the denominator cannot be 0. So my domain is all x such that x cannot equal 3 and x cannot equal negative 2. Now remember here that the domain is from the original function. It's not the simplified version. So here what I could do is I could cross out x minus 3, and I'm left with r of x is equal to x plus 4 over x plus 2. So part B, I have to find my intercepts. My intercepts, the y-intercept is when x is equal to 0. So I could use the simplified version. I'm going to have 4 over 2. So my y-intercept is 2. My x-intercept, I make the y equal to 0. So this is going to be the x-intercept is 0 is equal to x plus 4 over x plus 2. But remember, when I have a fraction and it equals to 0, I only really care about the numerator. So I'm going to have an x-intercept at negative 4. And then C, part C tells me that I have to find my vertical asymptotes. My vertical asymptotes will only be in my simplified version. Do not go back to here to find your vertical asymptotes. Use this. And it's when the denominator is equal to 0. My vertical asymptote is x is equal to negative 2. And then part D is asking for horizontal asymptote. And my horizontal asymptote is, now I have to check. I have even degree here, right? Power of 2, power of 2. When I have even power, the powers are the same. My horizontal asymptote, I just take the coefficient of my highest degree and just divide them. So this is 1 over 1. So 1 over 1, my horizontal asymptote is y is equal to 1. So now what I'm going to do is I'm going to find, does my horizontal asymptote, do I cross my horizontal asymptote? Letter E. Okay. So I'm actually going to erase part B for now. Actually, I'm going to erase part A and part B. So for part E, I'm going to take 1, and I'm going to set it to my simplified rational expression, which was x plus 4 over x plus 2. Now, if I solve this, I multiply both sides by x plus 2, and I get x plus 2 is equal to x plus 4. And then look, I have an inconsistent equation because the x's cancel and I have 2 is equal to 4. So I don't cross the horizontal asymptote. Okay? I don't cross the horizontal asymptote. So now we actually have all the information, and we could go ahead and graph this function. So I know I have a vertical asymptote at -2. So -2, I have a vertical asymptote. I have a horizontal asymptote at 1. Okay. I know I cross my y-axis at 2. That's my y-intercept is 2, right? And I know my x-intercept is -4. So even just looking at the values here, I know that since I cross the axis here, I'm going to be in the positive section, and if I'm across the x-axis here, I'm going to be in the negative. So this one is actually tells you right away that it's going to look like this. However, the directions say that we should test a point to figure out what the graph looks like. So what I'm going to do is I'm going to test the point -1. So I'm going to do r of -1, and I'm going to do it to my simplified version. So this becomes -1 plus 4 over -1 plus 2. And that is equal to 3 over 1. So I know at r of -1, I'm at 3. So at -1, I'm at the point 3. And see how the two dots kind of curve that way? So I know that I am going to graph it this way. I know that this is odd multiplicity, so I know it has to go down this way, and this x-intercept here confirms it. So what I'm going to do is I'm going to go ahead and graph it like that. So that one wasn't too bad. There was only one vertical asymptote, and we didn't cross the horizontal asymptote. Now let's move on to the next problem. The next problem is x minus 1 on top, x plus 2, and x minus 3. And then on the bottom, I have x minus 4 squared. Okay. Now, this is actually already simplified as much as it can because nothing can cancel. So what I'm going to do is I'm going to find my domain for letter A. My domain is all x's such that x cannot equal 0 and x cannot equal 4. Letter B, I have to find my y-intercepts and my intercepts for both. So what I'm going to do is my y-intercept is where x is equal to 0. So what I get if I plug r of 0 in, I get -1, 2, -3. Oh, I should have actually stopped. I didn't really need to do this because look, what's part of my domain? X cannot equal 0. So for the y-intercept, I already know, since x is 0 for my y-intercept, there is no y-intercept, right? Because x cannot equal 0. Now, my x-intercept is when y is equal to 0. And remember, if this is 0, we just care about the numerator. So this is really 0 is equal to x minus 1, x plus 2, and x minus 3. So my x-intercepts are at 1, -2, and 3. And they're all in my domain, so those all work as my x-intercepts. Now letter C is my vertical asymptotes. My vertical asymptotes are my denominator is equal to 0. So my vertical asymptotes are at x is equal to 0 and x is equal to 4. And then D, my horizontal asymptotes. Now, you have to think about this. What are the degrees of my numerator and my denominator? Well, my degree of the numerator is my multiplicity of 1, 1, and 1. So my total degree is a degree of 3 on the top. Then on the bottom, I have a multiplicity of 1 and a multiplicity of 2 here. 1 plus 2 is 3. So actually the degrees for the top and the bottom are the same. I have a degree of 3 on top and a degree of 3 on the bottom. So I take the coefficients and I divide them. Now you might ask, what are the coefficients? Because this is written in factored form and not polynomial form. But remember, if I do my binomial multiplication and then multiply it by x minus 3 again, that first term will still be x to the third. And then over here, x minus 4 times x minus 4 is something like x squared minus 8x plus 16. But if I multiply that by x, the first term will still be x to the third. So my highest degree term here is x to the third. My highest degree term here is x to the third. If I divide the coefficients, it's 1 over 1. So my horizontal asymptote is y is equal to 1. Okay? Now, let's see if we intersect the horizontal asymptote. So remember, what I'm going to do is I am going to set my 1 equal to the simplified version. And this is the simplified version. So I'm going to set 1 equal to x minus 1, x plus 2, x minus 3 over x times x minus 4 squared. I multiply both sides times x minus 4 squared, and I get x minus 4 squared is equal to x minus 1, x plus 2, x minus 3. What I'm actually going to do is I'm actually going to perform all of the multiplication here because I want to see if I could cancel things out. So this is x times, and x minus 4 squared is binomial multiplication. It's x minus 4 times x minus 4. So this is x squared minus 8x plus 16. And this becomes x squared plus x minus 2 times x minus 3. I just multiply that out. Now let's multiply this even further. This is x to the third minus 8x squared plus 16x is equal to x to the third plus x squared minus 2x minus 3x squared minus 3x plus 6. So it's quite a big equation we have here. Combine like terms. So I have x to the third minus 8x squared plus 16x is equal to x to the third minus 2x squared minus 5x plus 6. Hopefully I did all the math correct. And let me just check. Plus x minus 2, x to the third plus x squared minus 2x minus 3x squared minus 3x plus 6. Okay. The x to the thirds cancel. Okay. And if I move everything to one side, this becomes 0 is equal to 6x squared minus 19x minus 21x, sorry, plus 6. I think that works. Okay, and then can I factor this? I actually don't think I could factor this. So to find where it crosses the x-intercept, the asymptote, I might actually have to use the quadratic formula. I think for the test, I'm not going to give you something as complicated as that. Six times. Oh. Yeah. Okay, so I think we actually have to do the quadratic formula here. I'm going to erase that. I'm going to leave that here so I have that for my quadratic formula. X is equal to 21 plus or minus the square root of 21 squared minus 4 times 6 over 12. So that's x is equal to 21 plus or minus. Actually, I don't have a calculator on me right now. $431. $441. Okay, so this is kind of a mess now. X is equal to 21 plus or minus 257 over 12. And 97. Okay.